Hello students, today we are still on sets. We want to consider the equality of sets. When you talk of the equality of set, two sets A and B are said to be equal if A is a subset of B and B is a subset of A. Now what we mean by this is this. Now when all the elements in set A are the same element in set B, that means the two sets are equal. Now look at it. If in A you are having 1, 2, 3, 4, and in set B you also have 4, 3, 2, 1. You can see that all the elements in set A are inside B, and all the elements in set B are inside A. So it means that the two sets are equal. Set A is equal to set B. Now let's come to the concept of the universal set, the unit set, and the empty set. When you talk of the universal set, it means the set which contains all the possible elements under consideration. It's what we know as a universal set. Now it is denoted by this symbol or this. Now, when you say a unit set, a set which consists of only one element is called a unit set. So, if a set has the members of a set is just one, that is a unit set. Also, when we talk of an empty set has no elements. So when in a set it doesn't have any elements, so that it doesn't have any member, that is known as an empty set. So an empty set is denoted with this sign or this. Now let's go to the concept of complementary sets. A complementary set, that means a set given that A is a subset of the universal set. The elements of the universal set which are not in this set A constitute a set which is called the complement of A. Now let's do this. Now we use this sign to represent complement of a set. Assuming we are having set A, the complement of set A can be used. When you have this something like apostrophe or C on top, you show that what is complement of A. Let's look at this example. Assuming in the universal set, you are having from number 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in set A, you are having number 1, 3, 5, 7, and 9. The complement of A, you can see. So A complement, you indicate by this sign. A complement, it means that the elements in the universal set, but not in set A. Now you realize that here, in set A you have 1. 2 is in the universal set, but not in set A. So you write 2 down. Here 3 is here in A. 4 is in universal set, but not in set A. That's another element. 5 is already in set A. 6 is in universal set, but not in set A. So that means these ones are the ones that forms the complement of set A. 7 is in set A. 8 is in the universal set, but not in set A. So 8 is part of the complement of set A. 9 is in set A. 10 is in the universal set, but not in set A. So that means the complement of set A are all the elements in the universal set, but not in set A. So you realize that all the elements in the complement will not be, none of the elements in this complement will be in this set. So complement of a set are the elements in the universal sets, or the members in the universal set which are not in the given set, are known as the complement of a set. Let's do another example. if you have all integers. So you realize that in set A, you can say that in set A you are having integers. Integers are whole numbers. When you talk of integers, we mean whole numbers. And in set A, you have all odd numbers. Like the example we did here, in this in the verse said, this one are the integers, the whole numbers from number 1 to 10. In set A, you having odd numbers from number 1 to 10. You now realize the complement of set A are what? The even numbers from 1 to 10. So if you want to write it in verse, so you can say that if in the universal set you having all integers, that is all whole numbers. In set A you having all odd numbers. So it means the complement of set A will be what? All even numbers. Let's do another example. You are having, if in set A you are having letters of the alphabet, from the alphabet A, B, C, D, E, F, like that to Z. And in the set A, you are having consonants. You can say B, C, D, E, D, F, G, H, J. All these are consonants from the alphabet. So if that is what we have in set A, so it means that in the complement of A, it will be the vowels in the universal set, but not in set A. You can see that in set A we don't have vowels here, so we just have the consonant B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, Z. So the complement of set A will be the vowels. The vowels. So you realize vowels are part of the universal set, but not in set A. So the A complement will be the vowels in the alphabets, but no. So that means if you want to write this like this, you can see that if you having in the universal set you have all letters of the alphabet. In set A, if in set A you have all consonants, so it means that the complement of A will be what? All vowels. Now let's go to what we mean by the cardinality of a set. That is, you are talking about the number of elements in a set. That is what we mean by the cardinality of the set. Let's consider this set. If in this set we having A, M, B, D, and H. So here you realize that you are having 5 elements in the set A. So the number of elements in a set is called its cardinality. Since the set has 5 elements, its cardinal number is 5. So the cardinality of the set is denoted by write the number of elements in A. So if you want to talk of this, so the cardinality of this set will not be what? That will be 5. So you use it, that means the number of elements in set A is equal to 5, because we have 1, 2, 3, 4, 5 elements. So the number of elements in set A is equal to 5. Now we are moving on to the union of a set. The union of two sets is a third set which include all the elements of the first two sets. For example, if in set A you are having 1, 2, and 3, and in set B you are having 2, 3, 4, 5, and 6. So now A union B, it means that you combine set A and B together. So that means you having in A union B, when you marry the two sets together, all the elements in A and B are now brought together. So you having 1, 2, 3. So 2 is already here, you don't need to repeat it. 3 is already here, you don't need to repeat. Then you having 4, 5, 6. So union is a combination of two or more sets. When you combine the sets together and you use this symbol to represent union of a set. Also, now let's consider the intersection of sets. When you talk of intersection of set, it means that you are looking for those elements that are common in two sets, two or more sets. The intersection of two sets is a third set which includes only those elements which are in both of the first two sets. For example, if in set A you having 1, 2 and 3, and in set B you having 2, 3, 4, 5 and 6. So you now look at the two sets A and B. What is common to them? 1 in set A is not in set B, so that's not common. 2 is in set A, 2 is in set B, so you write it. So A intersection B will now be equal to, you having 2 is common to them, 3 is in set A, 3 is in set B, so write it. 4 is in set B, is not in A, no. 5 in set B is not in A, no. 6 is in set B, is not in A, no. So the two elements that are common in these two sets are 2 and 3. So use this symbol to represent intersection of sets. So A intersection B is equal to 2 and 3. So these are the intersection of sets. Now, let's now try to combine the knowledge we have been acquiring earlier to solve this problem. Now, you are given a question like this. This is used to represent the universal set. In the universal set, you have 1, 2, 3, dot, 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 10. It means that the numbers continues here till it reach 10. In set A, you having odd numbers up to 9. And in set B, you having numbers that are less than 7. So you are now told to write out the members of the following. This is 1, A complement, B complement, 3, A union B, 4, A intersection B, 5, A complement union B, 6, A intersection B complement, 7, A complement union B complement, 8, A complement intersection B complement, 9, A complement intersection A, 10, A intersection B complement, 11, number of elements in A union B, 12, number of elements in A intersection B. Let's start. First of all, when you are given something like this, you must ensure that you state all the members of such set clearly. Since in the universal set you have numbers 1 to 10, so you spell it out. In the universal set you write all the elements in the set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In set A, we are told that you have odd numbers up to 9. So you are going to state all the odd numbers up to 9. We have 1, 3, 5, 7, and 9. Those are the odd numbers you can see within 9. Then in set B, we say set B are numbers less than 7. So what are the numbers that are less than 7? We are having 1, 2, 3, 4, 5, and 6. So these are the elements of set B. So now, we are told to look for what? A complement. A complement. That is, what is in this universal set, but not in A. So let's look at it. Now, in the universal set here, you are having number 1 to 10. Then in set A, you are having 1, 3, 5, 7, 9. So what are in A complement? What is in the universal set but not in A? So you realize that what 1 is in A, that's not part of it. 2 is in the universal set but not here. So you pen now down 2. 3 is in A, no. 4 is in the universal set but not in set A. You write 4. 5 is in set A, so you know 6 is in the universal set but not in set A, so another number is 6. Then 7 is in set A, no. 8 is in the universal set but not in set A, so you write it. Then 9 is in set A, no. So 10 is in the universal set but not in set A, you write it. So the element of A complement will now be 2, 4, 6, 8, 10. So this is A complement. Now the second one says B complement. B complement is what is in the universal set but not in B. Now you realize that 1 is in B, no. 2 is in B, no. 3 is in B, no. 4 is in B, no. 5 is in B, no. 6 is in B, no. Then 7 is not in B, so 7 is part of B complement. 8 is not in B, so 8 is part of B complement. 9 is not in B, so it means 9 is part of B complement. 10 is not in B, so 10 is part of B complement. So the elements of B complement will now be what? 7, 8, 9, and 10. Now another one says A union B. You said union means when you combine two sets together. Now we having set A. This is set A, this is set B. So when you combine the two sets together, that is union. So let's combine them together. You have one is in set A and B, so you could just use 1 to represent them. 2 is in B, not in, so that means 2, we can write 2 again. I'm combining set A and B together. 3 is in both of them, just use 1, 3 to represent the 2. Then 4 is also in the two sets, you write 4. Then 5 is here, is in the two sets, you just use 1, 5 to represent them. Then 6 is in set B, you write it. 7 is in, so you write it. Then 9. So you realize that when I combine set A and B together, I'm having 1, 2, 3, 4, 5, 6, 7, and 9. So those are numbers that are repeated. You don't need to repeat them. Just use one of the one of it to represent them. So when I combine set A and set B together, I'm having 1, 2, 3, 4, 5, 6, 7, and 9. Now we also have intersection. A intersection B. It means what is common to set A and set B. So what are the elements that are common to set A and set B? So 1 is in A, 1 is in B, so that's right. 2 is in B, is not in A, no. So you have 3 is in set A and 3 is in set B. So that's another net number that is common. 5 is in set A and 5 in set B, another number that is common. 7 is in set A, not in set B, no. 9 is in set A, but not in set B. So you not write that one. So the elements that are common in set A and B together are number 1, 3, and 5. Now, we are also told to do A complement B. That is, first of all, we need to look for the members of set A complement. The other time when we did it, you realize that what we said, the members of A complement are 2, 4, 6, 8, and 10. And this is B, set B. We are not to union means that what you combine the set A complement and set B. When you combine these two sets, set B and A complement, so you realize you are going to get we have 1, 2, 3, 4, 5, 6 is in B. Then 2 is already here, 4 is here, 6 is here. Then we having 8 and 10. So when I combine complements, A complement and B together, I'm having 1, 2, 3, 4, 5, 6, 8 and 10. So this is a combination of A complement and B. Then the next one says that A set A intersection B complement. Set A intersection B complement. So you realize that here our set A, in set A he having 1, 3, 5, 7 and 9. Then B complement, as we have done earlier, we said the set contains 7, 8, 9 and 10. So we are now told to look for A intersection B complement. That means what is common to B complement? This is B complement and A. So 1 is in A, not no. 3 is here, no, not here, no. 5 is here in A, but not in B complement. No, 7 is in A and 7 is in B complement. You write 7. 9 is in A and 9 is in B complement. You write 9. So the two elements that are common in A, set A and B complement, they are 7 and 9. Now another one says that A complement union B complement. A complement union B complement. That means you have to bring the two elements in set A and set B together. So when you bring them together, so this is our A complement consists of 2, 4, 6, 8 and 10. Our B complement consists of 7, 8, 9 and 10. When you combine these two sets together, you having 2, 4, 6, 7, 8, 9 and 10. So the combination of these two sets is A complement complement union B complement. Now let us move on. If you are having A complement intersection B complement, so these are the elements in A complement and these are the elements in B complement. Intersection means what is common to set A and set A complement and set B complement. So the elements that are common to these two are what we have in 8 is in A complement, 8 is in B complement. So 10 is in A complement, 10 is in B complement. So the two elements that are common in these two sets is 8 and 10. So 8 A complement intersection B complement will now be 8 and 10. Another one here, you are having what? A complement intersection A. The element in A complement we having 2, 4, 6, 8 and 10. The element in set A we having 1, 3, 5, 7 and 9. So now intersection means what is common to the two sets. So now if you look at this, what is common to them? So 2 is here, 2 is not in A. 4 is here, 4 is not in A. 6 is in A complement but not here. 8 is here, 8 is not here. 10 is here, 10 is. So you realize we cannot find any element that is common in these two sets. So that will give us an empty set. So that means you can either use this or this to signify an empty set. Then we are told that look for A intersection B everything complement. So first of all, we are going to look at the element of A intersection B. We have done the elements in A intersection B are what? 1, 3 and 5. So now they have put everything in brackets. Complement means first of all look for A intersection B. So when we look for A intersection B, it gave us 1, 3 and 5. Then to now look for A intersection B complements, it means that you look at the universal set. We have numbers 1 to 10. What are the elements in the universal set? but not in A intersection B. So what are the elements here but not here? You have one is A intersection, we know. So 2 is in the universal set but not here, write 2 down. 3 is in A intersection B, no. 4 is in the universal set but not in A intersection B, write it. 5 is in universal set, no. Then 6, 7, 8, 9 and 10 are in universal set but not in it, so you write everything. The A intersection B complement will now be 2, 4, 6, 7, 8, 9 and 10. Now here they say we should look for number of elements in A union B, number of elements in A union B. So the other time when we combine A union B, we having 1, 2, 3, 4, 5, 6, 7 and 9. So how many elements are here? We having 1, 2, 3, 4, 5, 6, 7, 8. We having 8 elements in A union B. So that is why you have a number of elements in A union B is equal to what? 8. Because if you write the members out, you are going to count 8 elements. Also, they said the number of elements in A intersection B. A intersection B, the number of elements there. If this is A intersection B, we having 1, 3 and 4. How many are there? 1, 2, 3. 3 elements in A intersection B. So for the work practice, if in the universal set you having A, B, C, D, E, and in set A you having A, C, E, and set B you having B, E, list the members of the following set: A complement, B complement, A complement union B, A union B complement, A complement intersection B, A intersection B complement, A complement union A, B complement intersection B, A union B complement, A complement union B complement, A intersection B complement, A complement intersection B complement. Number of elements in A complement, number of elements in A union B complement. Please ensure you like, subscribe and comment on this video. Thank you.